Hello, my name is Christine G, and I am going to be going over this problem. And it says that we're looking for what size sample should be obtained if the researcher wishes to estimate the estimate to be within 0.03 with 90% confidence. And we're given a previous estimate, so let's go ahead and I had screenshotted this. Let's take a look at this. So here we've got this previous estimate of 0.32, and we know a couple important things. So the margin of error is at 0.03 and the 90% confidence. So the 90% confidence, we can just think of that standard bell curve, and 90% of the data, and this should all be looking symmetrical. So this is 90%, and to the left and right it's symmetrical, and so this would be 5% and then this would be the other 5%. And these critical values are 1.645, where that would be negative because it's to the left of the mean, which is in the middle, and then this one would be positive and to the right. The mean is always, we consider that zero standard deviations from the mean, is that because it's right there in the middle. So here we're going to be using this, and we'll take that 1.645 and then multiply that by the square root of the proportion estimate, which is 0.32, times 1 minus 0.32. So we're taking that proportion and just subtracting it from 1. And then here, this is the sample size, dividing by the sample size, which is n, and then equals the margin of error, which is 0.03. So now we just go ahead and do the math and solve for n. So the first thing I want to do is I want to get rid of the square root sign, because that thing is a mess. So here I'm going to square both sides, and it'll nicely get rid of it, because 1.645 is being times by everything under the square root. So 1.645, and we'll square that, and then this whole square root sign just drops off, which is pretty nice. And then we'll simplify here. So we've got 0.32 times 0.68 divided by the sample size. And then 0.03 squared is 0.0009. Okay, so now I'm going to do the math on here, and I take 1.645, square that, and then times it by 0.32, and then times that by 0.68. So then I get 0.58831, and this is being divided by n, and that is equal to 0.0009. Now I want to get n by itself. That's my goal. I want to find out the sample size. So here, if I multiply each side by n, and that's the same as n divided by 1 on this side, and multiply this side by n, then this n cancels with this one, and I'm just left with this nice number. And then over here I have 0.0009n. Now I want n by itself. So here I just divide both sides by 0.0009. Cancel these out. And then let's see. I'm coming up with n is equal to around 654.257. And the problem asks that we round up to the nearest integer. Because we can't have 0.2 people, we've got to be conservative and go with 655. And that is the correct answer on that one. So that looks good. So let's go ahead. I'm going to do another screenshot and we can take a look at this next one. This next one, they don't give us a previous estimate. So I like to think of, well, you know, if you have no estimate, then it's 50% chance either way, right? So the chance is 50-50, you have no idea. So here, same idea where we have this 0.03. The estimate has to be within 0.03 either way of this. So here we go and we look at, again, we want to find the sample that we need to obtain, and we have the same margin of error and then 90% confidence. So 1.645 we're going to be using times the square root 0.50 times 1 minus 0.50, which is just 0.50. Okay, divided by n. And this is all going to be equal to the margin of error, which is 0.03. Now again, same idea, we're going to be squaring both sides, get rid of that square root sign. So then we're left with 1.645 times square root 0.25. Oops. I'm forgetting to square everything. So 1.645 is being squared times, and then when we square this, we just get rid of the square root sign. And then I'm also going to simplify. So 0.50 times 0.50 is 0.25 divided by n. And that, we calculated on the last one, is 0.03 squared is 0.0009. So we're looking good. Now what we can do is we can go ahead and simplify this stuff, but we could also get rid of n right now. So multiply both sides by n, and our n will cancel here. That works out pretty nicely. And then here on this side we have 0.0009 n, and then here we have, let's go ahead and do this one, 1.645 squared, and then I'm timesing that by the 0.25, and I'm getting like, oh no, I did that wrong in my calculator, so hold on, let me do it again. 1.645, squaring that, and then timesing it by the 0.25, and then I'm getting 0.67650 and then I'm going to divide both sides by this 0.009 so I can get n by itself. And I just do the opposite function because 0.0009 times n, the opposite is dividing it by this, so I can get n by itself or isolated. So let me go ahead and divide by 0.0009, and I'm getting n is around 751.674, which makes sense. This is higher than this estimate because than this sample size because we don't have a previous estimate, so that would kind of make sense. Again, we round up to the nearest integer, so it would be 752 for our sample. Let's go ahead and check that. 752. And where's my mouse? it didn't work for me. So, but I'm pretty sure that's the answer, and yeah, it's not letting me submit it, but yep, that's the answer. So please let me know if you have any questions, and also if you want more videos, anything like that. I appreciate you watching, and thanks so much. Bye.